Hello, hello and welcome from Shiv Shankar Dayal. This is one of the videos on function pointers. As we have proceeded so far, this is part 58 and let me adjust the date, 7th November. So what are function pointers? So function pointer is a pointer to function. Its return type looks like this. You have some return type like a normal function. So for example, you can return int, char, or you can return a pointer to an element, or you can return a pointer itself, and you have your argument list. But the function name, which used to be plain function name, is now surrounded by two parentheses, and before that there is a pointer. This is the signature of the function name. But we will not really go into syntax at this moment. First we will see what it is and where it is used. So what we have discussed a little bit, that it's a function pointer, that is, it's a special type of pointer which contains the address of a function. It's so simple. Now the tricky part is, where do you use it? So one is you use it in callback mechanism, second is you use it in plugins and functions, and third is, fundamentally these two are dependency inversion principle. Now, what is dependency inversion principle? So Wikipedia, if you look up Wikipedia for dependency inversion principle, then it says high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend upon abstraction. So for example, if you talk of quicksort, qsort, then if you see qsort depends on a function called compare. Now qsort is a high level module and compare is a low level module, and clearly qsort does not depend on compare. Your compare function can be written separately other than qsort. The qsort's implementation is not affected by compare function. But both depend on what? Both depend on one abstraction. Now, what is the abstraction here? The abstraction is you can pass in any pointer. It's a generic void pointer. And the compare function will compare it. And this also is an abstraction because it is the most generic pointer, void pointer. You can compare two characters, two doubles, two floats. It's up to you. Or even you can compare char pointers. So that is your abstraction. Now this abstraction does not depend on the detail, that what type of value you are using. And the plugins and extensors are like DLSim. So how plugins are written? So suppose I have to create, for example, a text editor, plain text editor like Notepad if you are Windows, or gedit. So I have created a text editor. Now suppose I want to give a feature of plugins. So let's say I will create a function pointer. I'll call it C_highlight, or which will highlight the C source code. Now I will have a plugins directory. So when the system first boots up, it will look for a plugin with a particular name. Say for example C_highlight.so. Now if that particular plugin is available, then what I do is I open it and then I try to find out a particular function, let's say highlight_C. And if that function is found in that SO file, then I assign this function pointer the address of that by loading that into memory. And if that is not there, then C_highlight remains null and my original program will still work fine. So this is the mechanism of plugins and extensions. This is necessary because plugins are always written later than the main application. The main application comes first and plugins come later. It is never the case that the plugins will come first and application will come later. Therefore, the main application should give some sort of stub to which the plugin can register. If that mechanism is not there, plugin has no way of getting a hook into main application. And also, if plugin is written first, let's say for example plugin is written first and the main application later, then it is not really a plugin, because you can't simply write a library and then you plug it in. For example, a shared library. You simply can't write a shared library and plug it in. So the main application has to have that functionality from scratch. So these are the main uses. For example, suppose there could be, let's say this save icon is there, and if I click it, it saves the file. So it might be calling some other function. It may be a callback function which may be calling fwrite system call. I don't know. Maybe it is calling fwrite or fprintf, and it is printing to a function pointer by using a callback function. So this can also be manipulated using function pointer. That is one of your callback mechanisms. So I would suggest that you Google about these on Wikipedia and more about uses of C function pointers and try to learn more about it. I will try to give some simple examples, but my examples will be like toy examples, and qsort will be one of those. It is not possible to give DLSim unless I go through shared libraries. So plugins and extensions example I really cannot give, but I'll try to give more and more examples on C function pointers in coming videos. I'll try to give say 3-4 examples, and then we will see what is there. Possibly we can do file input output and then the bit manipulation functions and the bitwise operators. Thanks for watching the video. If you have liked this video, you can subscribe to my channel and hit like button also. Otherwise, if you really dislike this video, then you can click dislike as well. Thanks. Happy programming.